For our next session titled The Future of Orbital Support and Ground Infrastructure, please welcome Daniel Faber, CEO of OrbitFab, for a fireside chat moderated by Abby Remler, Director for Future Technology Platforms at SCSP.
Good afternoon, everyone. It is my pleasure to introduce Daniel Faber, CEO of OrbitFab, a company building the in-space refueling and logistics infrastructure that will underpin the space economy. Daniel, you have been a pioneer in the space logistics and tech world for a number of decades. I'd love if you could start by telling me a little bit about the journey that got you to where you are today, and also what inspired you to create what I understand is the trademark gas stations in space.
Yeah, thanks, Abigail. You could probably tell by my accent, grew up in Australia. There wasn't a lot of space industry things happening in Australia, but I decided when I was in undergrad and very starry-eyed, the most impactful thing that I could work on, probably the most significant thing since we crawled out of the ocean, would be to get off this planet. But not having a space agency or a large aerospace company that I can join, I wrote down a list of industries that I thought could pay for the first permanent jobs in space. That list was fairly short: asteroid mining, tourism, space-based solar power. After looking at that, crossing out space-based solar power, Mark was here on stage yesterday. The economics of that have changed a lot. 25 years ago, I had to cross that one out. Launch wasn't there, etc. I ended up deciding that I'd pursue all things related to asteroid mining. And so I got my engineering degree. I built a dozen satellites. I had to leave Australia and worked in several countries. And then started building companies, which inevitably brought me to the US. So OrbitFab is number 4. The last company was building thrusters to move satellites around in orbit, with the big, hairy, audacious goal of doing asteroid mining one day, because we built our thrusters on propellants that you could make from an asteroid, from that material. When I left Deep Space Industries and we sold that to a European thruster manufacturer, I was looking around at what would make satellites reusable. In the same way that SpaceX has made rockets reusable, that's created an enormous amount of value. So I was asking potential customers, customers that I had at my previous business, what it would be worth if we could get them more fuel in orbit. And I was absolutely shocked. The marginal revenue they could get for 1 extra kilo of fuel in orbit was $1 million, which blew my mind. And so that's what we do now. I buy fuel for $300 a kilogram and I sell it for $200,000 a kilogram.
It's amazing. I'd like to pick up on that and unpack a little bit more how orbital refueling changes the economics of satellites. What are the second and third order effects of that? How does it impact geopolitics? And are there any historical analogies that you think are fitting for what this could look like, or is this totally something new?
There are about 10 questions in here. We have about 3 hours, right? Gosh, where to start? I mentioned that $1 million a kilo. So when everybody hears about refueling, the first thing they think about is life extension, right? We put the satellite up, it's got one consumable, and that is fuel, and when it runs out, we have to destroy the satellite. You have to get it out of orbit. You don't want it to become debris, especially geostationary orbit. That's a very finite amount of real estate. And so you have to move it out of orbit. It's a legal requirement. And so being able to extend that life when 85% of the satellites are thrown away because they run out of fuel. They've still got operational transponders, and even if they're 20 years old, they're still generating millions of dollars. A couple of satellites, a year or so ago, there were a couple of satellites that they missed their lifetime by a couple of years. One of them they miscalculated. Turns out it's very difficult to measure how much fuel is in a tank in orbit. And so they had to write off 2 years of operations. The other one had an anomaly and used the thrusters to recover, but then lost 2 years worth of that operational life. They were $20 to $40 million write-downs or insurance payouts per year that they had to write off on a 20-something-year-old asset, which is phenomenal. And so for life extension, that's where that $1 million per kilo number comes from, because you invest everything in capital up front, you carry the cost of capital over the life of the asset. You also have to drag the fuel around, right? It's the rocket equation. If you can imagine buying a car with 20 years worth of fuel, or even 5 years worth of fuel, all the trailer loads of fuel you have to pull around, you're burning most of the fuel to drag the fuel around. So you're on a second exponential. And that's why even if it's $1 million a kilo of marginal revenue you can get, which is mostly profit because the capex is written off, it's not worth putting anything more in up front because you have to carry it for so long. And so that's obvious. What's less obvious is the fact that this is a paradigm shift and all the things that we've never done before. If you were to ask somebody, let's think about the days of sail, right? The ships were stuck, controlled by the currents and the winds. And if you ask somebody, what could I get you? Let's give you a motor to drive the ship, they'll say, well, I can get there quicker. But that's not the point. For ships, if you're upwind of an adversary, you own them. And the strategy was to wait until the wind was at your back, and then you own everybody downwind of you. As soon as you had an engine, coal or oil, you could be anywhere at any time on any ocean. And it fundamentally changed the strategic outlook of shipping. And there was a report written in 1884, right in the middle of this change to coal-powered ships, and it was also a time of great change in the technology of steel. And it was the first investigative journalism anywhere in the world, written by Smead, called the Truth About the Navy and Its Coaling Stations. And it did an analysis of the British Navy position, and they owned the seas. They were the undisputed champion of the seas, and the globalization and global peace was maintained by the British Navy. In that analysis, it looked at how vulnerable the coaling stations were. It looked at how the technology was changing, and a ship that was 5 years old was now irrelevant. And the position of the British fleet. And it resulted in a 50% increase to the British Navy budget. That realization that a paradigm shift was happening. So right now, when we look at space, it's not about life extension. That's not why we're doing fuel. But once we have fuel, you can do satellite servicing. You can upgrade payloads. You can change out the configuration of a spacecraft. You can move spacecraft around. And that fundamentally changes how we're going to be operating in space. The most exciting thing is, well, I've got a list as long as my arm of economic opportunities this creates. Most of the opportunities I haven't even imagined yet. That's how fundamental this paradigm shift is.
It's amazing. Let's start with geopolitics, but then come back to the economics in a little bit. You mentioned how the sailing age was rife with geopolitical dependencies or vulnerabilities. Is there anything similar that we should be looking out for today in the refueling space in particular, or space logistics more broadly? What are we seeing geopolitical adversaries doing in this emerging industry, and how should we think about that?
So, as a lot of people have sat on this stage and said, China is the pacing threat right now. A year after we started beating the drum and saying there's a paradigm shift coming of refueling, we really should start doing this. There was a photo that was passed around the internet showing a Chinese aerospace conference with a space oil tanker. 6 months ago, the Chinese refueled the first spacecraft in orbit. They had a spacecraft that was being quite active. It was investigating other satellites, starting to poke at American and allied assets. They'd towed a satellite to a different orbit, proving that they could really come and ruin your day if they wanted to. So the US had floated a couple of satellites over to check what it was doing. The Chinese launched a refueling spacecraft. They docked and refueled that spacecraft, that satellite, and then they burned 6 years worth of fuel in 10 minutes. Completely changed the orbit. And we're just stuck. Because if we burn 6 years worth of fuel to follow it, we've halved the life of these multi-billion-dollar assets. And who's to say the Chinese won't just burn again and go and refuel because they can? We are not winning this. They can now run circles around us. To quote General Gutlein, the Chinese are practicing dogfighting in space. Now, we've got multiple refueling missions happening next year. More in 27, a lot of fueling ports, interfaces that we're designed to getting installed on spacecraft. So we have the capacity to catch up, but we are not. We are waiting serially until things get tested before we build it in, before it starts becoming common, before we start looking at satellite servicing. The Chinese are just going, well, make everything happen immediately, simultaneously. We're going to lose this paradigm shift.
What would we need to do in order to win it if you still see that as a possibility?
We need to be a little more creative, and we need to lean into things. Well, we need to make sure that we don't compromise any assets on orbit by putting technology on there that, if it doesn't work, creates an issue. We need to lean into putting equipment onto the satellites that creates massive benefit if it does work. And that's an architecture that's easy enough to arrange. But it's not just refueling. I look at space situational awareness sensors. They should be on every single asset that we have in orbit. Of course, refueling ports. If you put a refueling port onto like the SDA satellites, the proliferated low Earth orbit satellites, right now, there's hundreds going to thousands of those satellites, and our adversaries are looking at countermeasures to how they take those out. But they're static assets. They know exactly where they are. In fact, the fuel on them is used to keep them exactly where they are. So it's really easy to track and to get at them. If you just put a fueling port on there, then an adversary has to plan for you to be able to maneuver. And at the first sign of an issue, we get scattered. Countering that capability is vastly more expensive than countering a bunch of what are effectively static orbits, static assets locked into their Keplerian orbits. So just putting fueling ports on everything, regardless of whether you ever use them, completely changes the way an adversary looks at your assets. Now, I go into a lot of other things that we should be doing, but we need to get going with this.
It's a great transition to talk about the role of government and the role of industry. Of course, the space age was originally a mainly government-driven ambition. That has changed today. So how do you see the role of government and the private sector, specifically in the orbital logistics, refueling, and space economy? What does that look like today? And how would you like to see that evolve?
Yeah, really good question. So we started the company focused on the commercial. We weren't even talking to the government, to the Air Force at the time. And so we talked to all of the satellite servicing operators. You can't do satellite servicing without refueling. You build a shiny tow truck, you tow a satellite or two, you throw away the shiny new tow truck because it just ran out of fuel. It doesn't work. And so there are obvious beachhead customers. We talk to the satellite communications operators who want life extension. And all of that, whilst sound economics, those companies have other problems to solve and other things to put their money into. They're not going to invest in a multi-year R&D program to create the technology. And they told us that flatly. Right? You fly it on orbit, you prove that it works, and we will come and beat your door down. But come back when you've got that done. Space Force was formed a year and a half after we set up the company. And we realized the government was learning how to spell satellite servicing. And so we engaged with the government, and we had to use our investors' money to fly demonstrations. We teamed up with NASA and the International Space Station National Lab, went to the ISS, proved out a lot of this tech, launched the first fuel depot with the interface, and that's what then got the government paying attention and starting to fund it. And specifically for refueling, that's important because we are not going to get there on the back of customer R&D money. Commercially, that doesn't exist. On the government side, that can exist. Once it's there, whoever owns that infrastructure and that technology is going to be able to leverage that from a national perspective to build the economy, to do the next things. Right? And at some point, the architectures we can build with spacecraft interacting in orbit fundamentally changes how you look at every spacecraft operations. And all of that requires refueling. So we need to get ahead of this, and then that expands both the national security and the commercial options. But the commercial guys won't pay for it up front.
It's clear that we need both government and industry, and there will be an enduring role for both. You mentioned before that a lot of the economic possibilities for what refueling could unlock, we can't even imagine today, but I'd like to ask you to imagine. what some of those could be. What are the ones that you suspect may happen in 10, 15 years? And what are some that would be really cool if they did?
Let me take a national security example.
Yeah.
Right now, we have the ability to look at satellites that are in orbit, find out what the capabilities are, and we do that from ground observations. We can do that from satellite to satellite observations. If you can imagine a satellite is launched by an adversary, we check out what it is, they launch another satellite, they go up to that first one, and they reconfigure it. All we know is that the shape has changed. We have to fly back and find out what it was. And then they just fly up and they do it again. And we have to go back and check again. And they've switched out a telecoms payload for a telescope. Or perhaps they took all the payloads off and we just wasted a whole bunch of fuel and a whole bunch of time with some really expensive assets to find out that it's just a frame and they took everything off. But then they go and visit again and we still don't know what's on there. Did they put everything back again? Everything is going to be reconfigurable in orbit, and nothing is going to be static. And we need to be the ones keeping everybody off balance and exhausting their logistics in orbit. Logistics is how the US has projected power globally. It's what supports our ability to win in any conflict. We need to have that logistics in space. At the moment, the only logistics in space is the Chinese refueled one of their satellites. But it's going to change everything.
What are some specific ways that we could improve how government and industry are working together? Are there any pain points that have come up in the public-private partnerships that if you were a policymaker and had a magic wand and you fixed this, it would make this a lot easier, for example?
Yeah, I'm a bit of a fan of economics, economic history. As you read like Adam Smith and some of the other fundamental economics texts, they're often tied to national security and military economy thinking, and the realization at some point in history that the ability of a nation to go to war and sustain a conflict, to, as General T. Ray said once, take a hit and be able to hit back. It's driven by how big your total economy is, because that's what you can tap in during times of conflict. That economy is easier to build and will be much, much larger if we build that based on a commercial economy. And that's the opportunity here. So we do this fairly well already. Support technology development and infrastructure that then is dual use and allows for a large commercial economy to be built that one day you can then tap if you need to. And I see that happening. So one of the risks is the government says, I'm going to build this infrastructure and own it, and no one's going to be able to get my strategic reserve of fuel in orbit. It's just for me. Another architecture is to say, we want this available commercially. We want it to be interoperable, and we want to have first dibs on it. So let's support building that. And that is where the government's looking right now. I think we need to lean in and double down on that. And that covers support for the technology, making sure that it's tested to the standards, making sure that the architecture is going to be useful in both contexts, and supporting the build-up of sufficient infrastructure that America can then take a leadership role globally and own this and build all of the spin-off business models that are enabled by it.
Spin-offs are sort of what we saw with NASA and a massive opportunity here that can really make the whole industry thrive. You mentioned standards and the policy space a little bit. What are some of the challenges there related to governance and safety and interoperability that we need to solve if we want to be able to enable this economic potential?
Yeah, there's a few different aspects to standardization and interoperability. One of the ones that's unique to satellite servicing and refueling is that for the first time we're looking at autonomous vehicles interacting in space, I say at scale, in quantity, not just ones or twos, and not with two spacecraft that were designed specifically to go together, but I've got a refueling vehicle and there's 100 spacecraft that I didn't build that I've got to be able to go and dock with. We need to have the confidence that we can go and dock without running a risk of impact. We need to understand the liabilities in case that does happen. We need to understand also when a third party two third parties do an interaction over here, there's a risk that they can impact the environment that my spacecraft need to operate in. Most obviously, if they screw up, they could fill the space with debris. And there's a risk that they're doing that to deny my access to that volume of space. So how do I know when that's actually an offensive maneuver that I really want to go and stop happening? And so we should be publishing flight plans. Just like we do with our airspace. We allow third-party nations and their actors to fly aircraft across our airspace, and we don't scramble the fighter jets every single time, only when they deviate from the flight plan. That's the kind of thing that we need to bring in. And as a commercial company, I want to be publishing that. I want people to trust me. There are big investments now in AI and in self-driving vehicles that allow us to make self-driving spacecraft with high reliability. But we need them within an architecture. We need the checks and balances on that, so we know the difference between a standard commercial operation and an operation that's outside of those norms that might be a risk.
Absolutely. Well, with our last minute and a half, we're at a space summit, so I would be remiss to not ask you about moonshots. We've done those in the past. America has achieved really incredible technological endeavors when we set a goal and rally the nation around it. If we wanted to own this paradigm shift that you brought up, what is the technical ambition that we should be seeking to achieve by, say, 10 years from now? What would you set that goal as?
Well, there are many goals that could be set, and many things that I'd like to see happen. Let me describe what OrbitFab's 10 to 20-year goal is, which I think is one of those and is valid. We're currently building the storage and delivery infrastructure for fuel in orbit. We want to become the refineries in orbit. We want to do the chemical processing. We want to be the biggest customers of asteroid and moon mine material. Ingest that material, turn that into the industrial chemical supply chain, and deliver air, water, 3D printer feedstock, minerals to grow plants, lubricants, like any industrial chemical to do manufacturing in orbit, as well as propellant. That's our goal. That serves an in-space market, which will then serve a terrestrial market, but also allow for the human expansion into space. And that I think is really important. In the next 10 years, whoever wins the economic expansion into space and the human expansion into space is going to dictate whether it's rule of law or rule of man, right? What are the norms? What is the culture? What is the language that's going to be spoken in space? That is how important this is.
That's a great spot to leave it on. Please join me in thanking Daniel Faber for our conversation.
Now we have a tech demo